Okay, so here's your lab. You're going to observe 4 photos of the Sordaria asci. They are labeled, so you can go, okay, that's card 1, that's card 2. Count 100 asci and keep track, of the total number of crossover you see. No crossover asci, and also the ones that are the non-crossover. Do not count the asci that are entirely one color, all tan or all black. They represent a double crossover, and we just don't want to go there, okay? Fill in the data table and answer the lab questions. This is a calculation that you're going to have to perform. You're going to need to do the number of crossovers that you observed over the total asci that you observed, the total number of spores. Does that make sense? And then you multiply that by 100, and that's going to be your percent crossover, okay? To get then what we call the map distance, and your lab sheet goes into a lot of detail about your map distance. The map distance is essentially how we're able to tell where chromosomes are located, where genes are located on chromosomes. And what we have found is that the farther away a gene is from the centromere, remember that's what binds the sister chromatids together, the farther away the gene is from the centromere, the higher likelihood of crossing over, okay? So if we have a high likelihood of crossover, we can say, and it is a reliable method, we can say that that gene is far away from the centromere, okay? So what we do is we take this percent crossover and we divide it by 2. Now that confuses people, but remember that stupid mitotic division that occurred randomly after both meioses and you felt like you were a champion, and then I said, oh, now you have this random mitotic division and it increased the number of spores from 4 to 8. Well, that's why we divide by 2, because the crossover really only happened to one of those spores, and we just happen to get the extra mitotic division in there. This answer, percent crossover divided by 2, is the distance between the gene and the centromere. So that's how you're able to find the map distance, the percentage of crossover that occurs for any gene. And again, it's a theoretical distance between the centromere and the center of the chromosome. That's right, the centromere is the center of the chromosome, and the gene itself, okay? The larger it gets, the farther away the gene is from the chromosome. All right, I hope this has helped you guys, because there's a lot of resources for you to kind of look this up and understand it. Again, the farther a gene is away from the centromere, the more likely it'll cross over. Genes that are very close to the centromere don't cross over. Genes that are near the ends of the chromosome will cross over more frequently, okay? Again, your test will be on, I will post it probably, I'm not sure. I wanted to post it just for one day only. So it pushed you to get it done. It reduced the chances for cheating. So I will post it on Friday. That means you need to get it done on Friday. If for some reason you're going to be gone on Friday, or you have some big thing happening on Friday, please email me and let me know. Otherwise, that test will be posted for 24 hours on Friday. The review has been posted. We are going to have a Zoom review on Wednesday. I will post the exact time on and the link on Google Classroom, so you guys have it there as a reference. Okay, good luck, and I hope everyone is well and doing great. I know you are going to do wonderful on this test. Okay, bye-bye.